saw some nods, but I'm with such a small room like this. I'm used to teaching classes of size of like 20 people or so, and this is about comfortable for me. So how is everybody today? All right, you guys ready to start DEF CON? All right. So for those of you who let's see, how many people were in my class earlier this week? 2 people actually came back. Man, that must have been horrible. Actually, the class that I had, which was covered, for those of you who were in the last talk here with Sean, covered a lot of the stuff he did. He kind of talked about, I spent a whole day going over all the specific details of everything, and we actually did it afterwards, which was really good. So for the 2 people that actually came back, what do you guys think? Really good? Yeah. So I thought it went really well. I got a lot of really good feedback from everybody, and so this kind of thing, and I realized why the room is so small, because I'm competing against Tim Mullen with his NIMDA backlash attack, which is amazing. And when I found out that I was speaking at the time slot, I'm like going, why can't I like change somewhere else so I can go to that talk? So and then the 0-day exploit that's coming out right now. So, and then of course people are leaving as I'm mentioning this, right? But I am going to bring up some good ideas, because with all the things that have been talked about with layer 3 and layer 2 exploits today, there's kind of got to be a way to put this stuff in such a way that it works. And I wanted to introduce kind of Cisco's design model, and then maybe what's emerging and what's coming up, and possibly a way to maybe get rid of some of the layer 2 problems. Now, we'll see how that works, and I like a lot of feedback from the people I'm speaking to. So if you guys have questions, don't hold back. I mean, don't even raise your hand. Just blurt them out and go with it, because if you looked at the amount of slides I have in here, I'm fully expecting lots and lots of questions. And that was the other reason, is I knew I was going to go against or right after 3 good talks on Cisco material. So I know those guys had chock full of information in there, weren't going to really leave a whole lot of time for Q&A. So I kind of did that on purpose, to leave some time so you guys can ask questions, and if I can't answer it, then I'll just track one of those guys down and bring it back in here. Oh, by the way, for those of you who got my business card earlier this week, if you could send my email to Yahoo instead of the address that you were given, it'll actually send mail to me. So, all right. So as for myself, my name is Steve Dugan. I am a CCSI. I'm a Cisco certified instructor. It's about 700 people that are certified to do this. That being said, I'm not a Cisco employee, which means I can stand up here and talk about this stuff in a way that the Cisco people can't. I can be honest about it, and I can tell you what's really going on and what's happening. That being said, I like Cisco as a company. I'm not going to bash them too heavily. But let's see. Tactics and Defentics, which was the title of my class and possibly upcoming books. Well, not possibly, they will be upcoming. Which stands for attack techniques and defense techniques. First one covering specifically all the Cisco attacks, tools to be used to run them, how to use those tools, and then possible defense mechanisms against those. So I'm hoping, if you guys see it on the shelves in the next 6 months or so, maybe take a look at it. All right, the agenda, introduction, I'm done with that. I'm going to go over the best practices for design, and this is really, the idea behind this is, so we talked about all the exploits, we talked about some of the ways to defend it, but let's look at the design model itself, and how do you build a resilient network and build it securely? It's really a, kind of got to, be kind of even about how you want a network that runs, but, the securest network is just unplug everything and just give up. But that's not really an option. So, and then I'm going to go into some possible new ways that we could design our network. And although the one limiting factor of this emerging design is cost, because right now the equipment that you would need to run the new emerging design just is too ridiculously expensive, it makes sense because it gets rid of a lot of the problems we're seeing right now. It's It's certainly not an end-all. It's not the best case scenario. I mean, the best case scenario right now, with all the things you've seen, the best case scenario would be for an administrator of infrastructure equipment. And we're talking like, basic intro level. I just learned what iOS stands for. Okay. I just learned this information and I want to be able to set up, I don't know, pick a protocol. Spanning tree, OSPF, EIGRP. I'm not going to give BGP to the intro guys. Okay. If those guys set up those protocols, it should be encrypted on the wire between any other Cisco device that's out there without any configuration other than maybe a password. That would be ideal. Do you guys not agree with me? It should be that easy for that administrator to do it. Right now, you can do it. You can, but it's too ridiculously hard. Maybe the people in this room, some of the people in this room could pull it off. But how many people think that the junior administrators, the guys who just got their MCSE and now just learned a little bit about Cisco, do you think they could pull it off? No, not going to happen. So the only way to really do it would be to design the code itself to encrypt right at the wire without any configuration. That's the default. If I'm going to turn on this protocol, any packet exiting the router or switch that came from the router or switch should be encrypted and specifically targeting another device, or with OSPF's case, I don't mind that OSPF does a multicast and is looking for other routers, but on that respect, anything beyond that multicast address saying, hey, this is OSPF, it's all encrypted. And you have to have the specific password, and everything else behind it, is hashed. So that's just kind of where things should be, but that's not what I'm going to talk about in my design stuff. So, all right, current design model, and this is really based from a campus perspective. In the campus design model, the current best practices that Cisco has is this building block design idea, to where I can create user blocks, server blocks, WAN blocks, internet blocks, and so on, in such a way to just kind of bring about a cookie cutter approach to a large enterprise. Why reinvent the wheel over and over and over and over again? So how this is done is it's a three-tiered model. You have the access layer, a distribution layer, and a core layer. There's arguments back and forth as to whether the core should be layer 2 or layer 3, arguments of whether or not you should connect the two distribution layer boxes or not. But the reason, why would I build this? Why would I build it this way? What am I looking for in my network? We're obviously here in a security conference, but what happens if a box fails? And through no other reason, nobody attacked it specifically, it just went down. Or even better, as an administrator, you need to upgrade iOS because you find out that this box is vulnerable. And we had the same thing the gentleman, Richard Clark, at the beginning of the keynote address said, hey, the reason some of these attacks are still working is because you can't take the network down to apply the patches, to apply the fix. Well, if one of my boxes fail, or I have to take it down out of service to upgrade it, and the network goes down because of that, isn't that a denial of service in its own right? Okay. Isn't it a denial of service, or certainly a denial of livelihood, that we have to force engineers to come in at 1 o'clock in the morning to upgrade code because they can't do it while users are on the network? So a truly good design model should take that into account that I should be able to take one piece out, and rather not just one piece out, but one piece out of each of these blocks, and the network won't go down. It won't have widespread effect on the entire network. I use often what I call the dartboard test when I'm evaluating networks, and showing them. And this works really well in like the boardroom. You take the Visio diagram of the network, you put it up on the wall, and you hand the CEO or whoever the decision maker that's in the room, you hand them the dart and say, okay, go ahead. Plunk. Now, wherever that lands, hopefully it lands on something. It's on the piece of paper instead of just white space. Whatever that piece was, that just went down. What happened to the network? Well, 9 times out of 10, the network's down. Or there's serious consequences to the failure of that one piece. Now, it doesn't matter how it went down. It's down. We need design models that do this. And this design model's been around for a couple years, maybe even a little longer. It's taken a lot of revisions. We started off with the flat network, with hubs all over the place, and that didn't work. So everybody went to switches, and we just ran switches all over the place, and that didn't work. We ended up with broadcast norms all over the place. And then we went to VLANs and routers, and that kind of worked, but then we still ended up with broadcast norms because they still ended up getting too big after a while. And now we're kind of looking at this for a large enterprise design, where I can take my users, put them in a user block. I can take my servers, put them in a server block. I can apply access lists and apply security mechanisms in a manner that makes sense. I can apply access lists coming into and out of a block in such a way that allows users to go certain places, disallows traffic coming in and out. But it also formulates it with layer 3, things like route summarization and all this other stuff that's very helpful. Okay, let's see. Now, as far as the dartboard test, going back to that, when that fails, it proves to people that that type of network design just doesn't work. What do you do? Well, about the only place you can't provide true resiliency is right down to the access layer. Why not? Why can't I provide a resilient access layer where the users are plugging into the network? What would it take? Resiliency in the host? Yeah, two PCs on every desk? 2 NICs? Okay. Well, 2 PCs on every desk would be Microsoft's best, would be like their biggest dream. They were, their old saying was 1 PC in every house, right? Now 2 PCs on every desk. But two NIC cards, right? Or at least 2 drops to every desk. And then when the upstream device fails, we have to get on the PA and go, okay, can everybody flip over to, move their cable over to the other port? Yeah, that's going to work, right? So that's a place where we can't really provide true resiliency. But if that box fails, how many users are we talking about? That's the question, right? If you build your access layer with switches that are 6509s with 400 ports, then yeah, if it goes down, you're affecting a lot of people. Why not build the access layer to really a small port density, something like 24 ports, 48 ports, which, by the way, the port densities and the port numbers on Cisco boxes never made sense. I mean, they're kind of like hot dog buns and hot dogs. Okay? You get, 10 hot dogs and 8 hot dog buns. Okay? Well, it doesn't make sense because, our IP addressing schemes don't work out to 24s and 48s. Okay? So, I digress. Okay, but everywhere else, above the, anywhere after the access layer, we can provide resiliency. And, well, we do have an option for resiliency of the access layer, and that's buy an extra switch. Of course, again, Cisco's best thing. But you have 9 access layer devices, you buy a 10th. And the 10th one sitting in the rack is not even plugged in, and you have the configurations for the other 9. Should you have to take one out of service or it goes out of service for whatever reason, you take the configuration, you put it on the 10th, you move the cables over, and everybody's up and running. Maybe takes 15 minutes. And you're out of service for 24 users as opposed to a whole network worth of people, like what could happen if a core box goes down. So it's at this distribution layer, at the core layer, that we really have to worry about resiliency. The fact that if a box goes down, it could affect a lot of people. So that's the whole idea. So the features of this design, and this is really taking one block, and I'm going to focus on the user block for now. The features of this, and the Cisco design model, it works with spanning tree and HSRP to provide all of these features. And I'm going to list them off here. So we have link redundancy, and I've seen a lot of people implement this, and I go and look at it, and I find that the two uplink ports going from an access layer switch over to the distribution layer switch are just so happen to run in this very same conduit all the way back towards the server room. And then I don't know, to give an example that happened in my early days of consulting, there was a large building in Oxnard, California, that the air conditioning unit was on the ceiling, broke. And all the water from the air conditioning unit started flooding into the conduit all the way down the building. And situations like that, where you have your wires run in the same conduit, can create some problems. So it's a good idea, if you're going to do this, to separate them out and go via different conduits. So link resiliency. If I lose a link, I can still go the other direction. Load sharing. Well, that becomes an interesting concept, because what happens to spanning tree when you have a loop? For those of you who were here last talk, what happens? It doesn't work. Blocks, right? So one of the ports is blocking. Well, if you have one spanning tree domain in this whole thing, effectively what will happen is one switch will get all of your traffic. One upstream distribution layer switch will get all of your traffic, and that's it. The other one will sit there and going, hey, I'm resilient, and I'm sitting here, and you spend a lot of money on me, but you can't use me because I'm blocking. So the model with which Cisco decided to do this is rather complex, but it works. And that is to take, on the access layer switch, to take two user VLANs and have one user VLAN go to one upstream distribution layer switch, and that becomes the root for that VLAN. Just go out. Okay. And the other VLAN, the root is on the other box. So it creates two separate VLANs, spanning tree domains, to where we can really load share these uplink ports going towards the distribution layer. And you get to use both boxes. Going beyond that, then we start looking at things like default gateway redundancy, essentially HSRP. Now, why do we need HSRP? Well, can you put two default gateways on a Windows X machine? And I don't mean the entry place that you can put them in. I mean, does it really take a second default gateway? No, it doesn't work. So, okay, these upstream distribution layer switches, which have to have routers in them to work and operate with this design model. So you do have to have routing functionality, some layer 3 functionality at the distribution layer. If I pointed all my clients towards one of those distribution layer boxes, and that distribution layer box went down, even though I had another router in the other one, none of my clients would be sending any traffic there. So I have to implement something like HSRP, which is horribly insecure, because it's not only does it send its messages on 224002, which is the all multicast, all router message, but it's in clear text as far as the passwords are concerned. Now, VVRP, which is up and coming, and I haven't tested to see if it really is running on 12.2, is rather new. Maybe that'll be a solution later on. But there's still so many people running HSRP that creates a problem. We saw on before, and if you guys have questions on how the HSRP takeover type attacks work, it's as simple as plugging a machine in, saying, "Hey, I'm the HSRP, active router," and the other ones go, "Okay, sure, here you go. Here's all the traffic. Here's all the traffic." All you do is send a static route back to the original active router, and you're sitting in the middle of all the traffic. It's very, very simple. So for a feature that's used so widely in Cisco land, to have it not secure is just, it's a crime. I mean, it really should be, it should be taken care of. But this design model takes, it really relies on that protocol as one of the things it has to do. It really relies on spanning tree to provide the load sharing, and it works. It does work. And Cisco's added features into this decrepit old protocol, spanning tree, and they keep massaging it and adding features, and oh well, let's fix it up a little bit here, and things like uplink fast, where I know as an access layer switch I've got one forwarding port and one blocking port. Should that forwarding port go down, I immediately flip over and I now run forwarding on the other port. It takes about 2 seconds. Oftentimes don't even drop a ping. And that works great because with regular spanning tree it'd be 50 seconds and you would start dropping TCP sessions. Things could potentially stop working. Okay? Maybe. But it's enough for a user to notice it if it wasn't running. So there are things there. It's manageable. In small, in these blocks you can deal with, a simple design. If you let spanning tree go crazy and, you don't build a design like this, you don't know where the root is, you don't know what paths are forwarding and blocking, you have to have this massively intricate map of all your ports going everywhere to figure out what's a blocking port and where's a forwarding port, where the traffic's going throughout the network, and it doesn't make sense. Spanning tree in its own right, in order to be manageable, has to be kept simple. And in this case, we end up with, triangles or V's, very simple spanning tree domains. Let's see. So it also has to be scalable, of course. We don't want to have to forklift upgrade everything, and as we know, issues with security. So some layer 2 functions mentioned. Root guard. Root guard is a good security feature that stops root takeover types attacks. If I send a BPDU message out from a host or from maybe a compromised access switch, hey, I want to be the root. The upstream 6509s or 4000 cat switches can kind of squash that and not allow you to do that. Port fast. Port fast is one of my favorite features as far as, for a couple reasons. Not only from a security perspective, but from a, just from the fact that it works really well and it solves some of the problems I've seen over and over and over. One of those problems is you turn on a PC, and let's say it's rather fast. You turn on a PC, it comes up, and the first thing it sends out is, pick a protocol. If it's what we're usually using, it sends out a DHCP request. If it's something older, maybe it's get near a server or a, heaven forbid, a seed for MAC addresses. Okay, wants to start flooding out MAC, getting out MAC information. I can't remember the darn protocol. If it's running spanning tree, that port came up. It's a spanning tree topology change. Spanning tree topology change take about 50 seconds to figure out what's going on. In that it's figuring it out, within that first 50 seconds, you're sending these messages to get your addresses. It's throwing away your packets. So you end up with the users calling up going, hey, every time I turn my machine on, it doesn't work. What do I do? Well, do a release renew and everything works. With port fast, it also does something. It does something from a spanning tree perspective of it sets it to a forwarding mode always. As soon as the port comes up, it's forwarding. So since it's forwarding, as soon as it comes up, user sends information, no problem. Couple that with BPDU guard, and now you have some problems that are taken, some security problems that are taken away. I can't start sending packets upstream saying, hey, I'm a switch. Even if it's an accidental type thing where junior admin plugs a switch into another switch and possibly creates a loop, this BPDU guard protocol should be set to shut down and shut down that port. Okay. A lot of attacks can be mitigated with that. Port security. If you've heard about the MAC flood, the CAM poisoning type attacks, port security should be turned on. Turning port security on all the way down and tweaking the nerd knob so it's one MAC address per port will create a ridiculous amount of time you're going to be spending tracking every single MAC address and sending somebody out with an Excel spreadsheet to say, okay, this user's on this port with this MAC address, and map that to your entire enterprise. And every time there's a change, somebody has to go back, and it doesn't work. Okay. I've seen people try and implement it. They try it for a little while, and it's just not possible. Okay. But what does work is setting port security and giving it about 128 MAC addresses. I can learn 128 MAC addresses on this port. Well, if you send more than 128, I'm going to disable the port. Well, the only reason I'd send 128 MAC addresses upstream is if I'm trying to attack. Management VLAN. The idea of a management VLAN on a per switch block type basis is that we have one management VLAN carrying all the traffic that the users shouldn't see. Again, things like spanning tree updates, routing protocol updates, things you can't really do with a management VLAN, and this is a thing that's rather disappointing, is HSRP. Can't keep HSRP away from the user because of the multicast address it's sent on. There are some ways to statically map the MAC addresses, the multicast MAC address to a port that potentially in some boxes I've seen results on where it can work. But it takes away, if you're doing any kind of multicasting like multicasting intelligence at the switch, IGMP snoop or even CGMP at the switch, you lose that functionality if you start mapping those things to switch ports. So the management VLAN won't carry HSRP, but you can use it for everything else. You can use it for carrying, making sure your routing protocol, CDP information, VTP, all this stuff that you don't want the users to see, you can keep it away from. And what's the default management VLAN? VLAN 1. And what's every port on every switch is defaulted to what VLAN? VLAN 1. So what's the most insecure VLAN we have? VLAN 1. Shouldn't carry VLAN 1 on any of your trunks, although it's still hard-coded for a lot of boxes to carry that information over VLAN 1. Can't do much about it. You still shouldn't have VLAN 1 going out to the users. You should have messages indicating that somebody turned on VLAN 1. For those of you who know about private VLANs, what do you think of it? The idea of it sounds cool, right? How about the implementation of it, and the actual setup and really deploying the idea of private VLANs in a user block? Not going to work, right? Users can't talk to each other. So maybe we have to come up with a better idea that still gets the idea of private VLANs. The idea that we can have one user and one default gateway, but that's it for that one VLAN. That's an idea. All right. I mentioned layer 3 functions of security as far as running layer 3 capabilities at the distribution layer. This is where we're going to apply our security policies for this block. Inbound, outbound, to and from the particular block, route filtering, route summarization, other things that we should be doing. The idea of network-based IDS, I'm still not a true believer. Maybe some of you guys can convince me of it, but I just still haven't. I haven't been convinced of the usability of IDS and the fact that I see so many false positives with it. Maybe somebody in here can convince me of it, but for now I just I'm still in wait and see mode. All right, so I mentioned some of these hard issues to deal with. First was HSRP. HSRP, clear text password, that's about as bad as it gets. The fact that we can do a takeover with it. Some other interesting things that were found with HSRP that can be used for remote, via the internet if you're not really careful at the firewall. We can send HSRP messages not to the 224.0.0.2 address, but to the address of the router itself, saying, hey, we're HSRP and we want to take over as gateway all the way across the internet, and it'll let it. Which means neither of the two routers you have in this segment will be forwarding traffic for anybody. Rather nasty. Of course, that requires, if there were passwords in place, that would require some knowledge of what was going on, so maybe a little harder, but you could still brute force it in a lot of cases and figure out what the password was. Layer 2 weaknesses, spanning tree specifically, ARP, spoofing as well. A lot of solutions. What do you guys like? I mean, there's a lot of solutions. We've seen all the weaknesses. What do you want to do about it? I mean, it's still a situation where we got to really talk about what to do about spanning tree and ARP weaknesses, because they're there, and they've been there for 3 years since I really started seeing all of these things. They've been there longer than that, but when people really start attacking it, and we're going to be talking about this every single year until somebody starts doing something. Some things are getting done. I don't know if it's fast enough, but all right. Some other common things, common misconfigurations of these. VTP. VTP is my least favorite protocol that's run on Cisco boxes. Some of the things I've seen. Most common story I hear about VTP, and I hear this over and over and over. You're an admin, sitting at your desk, somebody comes and brings a brand new switch and puts it there and says, okay, you need to learn this, and you have a week, and you can learn everything, every option available on this switch, get to know it really well because we're putting it in our network. So you sit there for a week and you play around with every feature you can play with. You play with all the VLAN stuff. You play with all the protocol features. And you delete and add VLANs. You're dealing with VLAN stuff. And then somebody says, OK, time to put it in the network. So you clear the config. You plug it into the right spots. And the first thing you want to do is you want to learn all the VLANs in the network. So you add them to the VTP domain. Every single VLAN in your network just got deleted. Oops. Now, why'd that happen? Now, I cleared the config, but what wasn't cleared with VTP was the sequence number. Sequence number changes every time I add and delete a VLAN. And the person with the highest sequence number is the one who has the master database. So what happened was you added this switch with a clear config, put him on the domain, and he said, hey, I know about the VLANs, and my sequence number is 4,712. What do you guys have? 5? Oh, okay, I don't have any VLAN, so delete all yours. Oops. That's what I refer to as an ADOS, an administrative denial of service. So that one I see frequently, and it scares me with VTP. But if you look at this design, do you need VTP? From this design perspective, I need 3 VLANs per access layer switch. I need a user VLAN, I need, 2 user VLANs, and a management VLAN. The idea of VTP is to make your job easier so you don't have to run around and configure VLANs everywhere, but we're talking about 3 VLANs. Okay? 3 VLANs on all these access layer switches. I mean, I don't need the protocol. I really don't. Maybe upstream of the distribution layer between those two, you may have 100 VLANs or something, but cut and paste does the job just as well if they're the same boxes, which oftentimes at the distribution layer you're dealing with 2 identical pieces of equipment. All right, so some ideas I'm having in as far as design changes. Now this is a rather unique concept, although it's been tried before. The idea of bringing layer 3 functionality all the way down to the desktop. Now this is my idea, this is not Cisco's idea. I'm sure somebody from Cisco is probably going to come up and tell me how it's not going to work, but I'm going to stand behind it until I can see otherwise. Here's why. If we bring routing all the way down to the desktop, and granted this is a rather expensive thing to do, but if we can bring routing functionality all the way down to the desktop, we can get rid of a lot of protocols. The more protocols we can get rid of, the less problems we're going to have. What can we get rid of? I can get rid of spanning tree effectively. I can get rid of HSRP effectively. I can get rid of ARP spoofing problems. Because if we have because we can implement right now with equipment that's already out there, we can implement the concept of private VLANs. Simply. Not with the ridiculous amount of configuration it needs to do private VLANs. You can do it now with boxes that are in existence. In particular, the 3550 or the 2950 switch. The idea is that it's a very simple concept. Let's just put every port on a different VLAN. Every port on the switch on a different VLAN. Keep the design model the same. The access layer is the only thing that's going to change here. So if I have every single port on a different VLAN, and I have a routed interface for each of those ports, and the routed interface being a virtual interface on the device, I've effectively turned my 3550 switch into a 3550 router. Now, this is going to take a lot of subnets, but if you're using private address space, it doesn't really matter. It's also going to take away spanning tree from the standpoint of this load balancing. Half the VLANs go this way, half the VLANs go this way. Just run OSPF. Run EIGRP if you like EIGRP. I'm an OSPF fan myself. Although, well, depends. Tuesday I might be an EIGRP fan. Wednesday I'm an OSPF fan. Depends on the version of code and the problems I've seen with either revisions of it. So, but let me show a diagram of what I'm trying to talk about here. As far as the access layer, all we're doing is that we're extending layer 3 down to the access layer. That's the idea of this emerging design. And the only thing limiting us here really is cost, and that's going to change shortly. Everything else everything else stays the same. The infrastructure design all remains the same. It's still a question of whether or not we need the redundant link between the distribution layer boxes. Layer 2 or layer 3 at the core is still a question of preference. And the reason why layer 2 or layer 3 at the core is an issue is that it depends on really how many switch blocks you have. Because for each of these distribution layer boxes, we have to have routing engines there. Well, if we're running layer 2 at the core, you end up creating, if you have a lot of switch blocks, you end up creating just a huge number of neighbor relationships with your routing protocols. And for every neighbor relationship you have to maintain a database of routes for that neighbor. And you're also, multiply connected across this core via layer 2, so you end up with, a rather large database. I've seen as many as 30 pages. You do a show, IP, EIGRP topology, all, and you just see this huge spew of information come out, and that's all. It's tremendous. So what do you do to fix it? Well, you run layer 3 at the core, and now I only have to peer to my upstream core device twice, each core device, and then that's all the neighbors I have to create. Another common misconfiguration is if there's a link between the two distribution layer boxes. You're setting up EIGRP, and you set up EIGRP by the network statement, and here's the network I'm running. It's 172.16.0.0, but I have 100 VLANs, and every one of those VLANs is on a different subnet on that 172.16 network. And although everything looks normal, looking at the routing table, if you look at the topology table, you've just peered across the trunk link between the two distribution layers on every single subnet you have. It's a separate neighbor. So, you have 100 subnets running across the trunk link there. You have 100 neighbors between the two distribution layer boxes, which quickly uses quite a bit of memory. Right. The only way to spot that is to do a show IP, OSPF database, or to do a show IP OSPF neighbors, shows it quickly, or show IP EIGRP neighbors will show it rather quickly. How do you fix that? By now? I think I heard it. Louder? Multiple areas? No, that's not going to help it. Summarization is not going to help it, because we're talking about a network command that turns up interfaces and says this interface is running your protocol. And this interface is going to start sending hello messages out for this protocol. And we'll establish a neighbor relationship across here. Now, we're talking about trunk links, so every time it goes on an interface, it's adding the VLAN tag on top of it, so it appears to be a completely separate logical link, different neighbor. What we need is passive interfaces. OSPF has the ability to be a little bit more specific. I can say this one interface because I can put a wildcard mask on it. They just happen to add that into EIGRP in the last 12.1 rev. So you can add a wildcard mask at the end of the EIGRP network statement to make sure it only appears on one interface. Very, very common misconfiguration. But. All right, so back to this. Why layer 3 at the access layer? So I mentioned HSRP isn't needed. Well, look at what we have. If we're running layer 3 down here, and it doesn't look like a router from this picture, but if we're running layer 3 down at this box, HSRP isn't going to help it. HSRP is not a routing protocol. It's a router redundancy protocol. It's for default gateways. If your PC is hanging off this access layer box, and the access layer box becomes your default gateway, I don't need redundant gateways upstream, because if the access layer box dies, I don't have a default gateway, I don't have a way to get out. So HSRP becomes a unneeded protocol. One less thing to worry about. Don't have to worry about VVRP. Whether it's secure or not later on, whether it works later on, we don't have to worry about it. It's no longer part of the design. Routers will talk to each other and exchange routes because they know how to talk OSPF and EIGRP. The other one, spanning tree. It's irrelevant in this case. Every single port on the access layer switch is on a different VLAN. Even if you were to take two cords and plug it into two different ports in the switch, it doesn't create a loop. Because it's going to go from VLAN 6 into VLAN 9, and those are attached to a logical interface inside the device. It's still not an Ethernet loop. You'd have to do something completely on their side, and really you're talking about taking out two ports, not the whole network. You could effectively turn off spanning tree with this. Wow. That gets rid of a lot of problems, doesn't it? Now, until I started doing this design and looking at it, I hadn't seen an effective way to turn off spanning tree. I would never, ever tell anybody to turn off spanning tree because it was too scary. But if you're layer 3 on every single interface, every interface on your box is on a different VLAN, it's a router effectively now. Spanning tree doesn't matter. Let's see, what else? Routing to the distribution layer. Okay, so now we don't have to do the half the VLANs one direction, half the VLANs the other direction. We don't even need trunking. So we don't have to worry about VTP, VLAN trunking protocol. Excuse me, not VTP, although we don't want that anyways. But we don't have to worry about DTP, dynamic trunking protocol, because we're not going to trunk. We're just going to run access links all over the place, and each one of these access links are routed interfaces. So now with OSPF, it will load balance all your traffic upstream to your distribution layer automatically because that's what it does. It already knows how to load balance. It's a routing protocol. What I'm really trying to say with all this is spanning tree bad, routing good. Okay? In a nutshell. The idea of private VLANs, the idea of private VLANs are still useful in the service provider, I want to set up a server farm type environment. But from a user perspective, it doesn't make sense. But the concept, the idea we like about user VLANs is that we can create an isolated port that says this port has one default gateway and can't talk to anybody else unless I create rules that say they can talk to other people. Well, in this case, if we're going to be routing, everybody will be able to talk to each other, which is nice. I don't have to worry about it. But I can create one routing interface inside of the device. We have a default gateway for each machine, and it's done. We could still have some issues with, obviously, with the configuration of DHCP. It would make DHCP configuration rather ridiculous. That's one of the downfalls of my design, and I will readily admit that. So you could do this with static addresses rather easily, but of course that certainly takes away the idea of DHCP, takeover attacks and all the things you could do there. The other things you could do is put IP helper on the routed interface and forward specifically just the DHCP request, not all the other things that IP helper sends, things like TFTP and TACACS and time and NetBIOS, both the NetBIOS ports, all get sent with IP helper. Just send the DHCP request specifically to the server. That'd be great. Or run DHCP right at the 3550 since that's what it runs. And even if somebody ran an exhaustion attack for DHCP, what are you going to take over? The other users on this box? Maybe. You could do that. But you could set that up in such a way that you could stop it since you have control there at the box. The other nice thing about this is you can replicate it. The design, the only thing you'd have to change once you got the design in place for one particular access layer box is just to repeat it and change the IP addresses. Nothing else changes. Passwords would be nice, but so it's very easily repeatable over and over. Repeatable over and over. Yeah. All right, so as I mentioned, some of the security problems that we solved. ARP spoofing, didn't mention that. Who are you going to ARP spoof? You're going to ARP spoof your gateway? You're the only one on the VLAN. Hey, me and my gateway, I make sure I can talk to the gateway. See what's in the middle. There's nobody else in the middle. It's you, your gateway, and that's it. What are you going to ARP spoof? That's a rather tough problem that we try to deal with to get rid of. Root takeover attacks. There's no root. There's no spanning tree. Nothing to take over. HSRP man-in-the-middle attacks, right? Or denial of service attacks with HSRP, as I mentioned. We're not running that protocol anymore. We don't need it. Problem solved. Other things that we can do that are helpful, because the boxes that I'm talking about, the 3550, the 2950 with the routing capability, because they are QoS aware, now I have these features such as NBAR brought all the way down to the desktop. I can really use the quality of service features because they're right there at the desktop. It extends the trust boundary for quality of service all the way down to the access layer. So I can stop the user denial of service attack. You guys all know the user denial of service attack, right? That's the, one second, finish my sentence. That's the, 15 users are doing file sharing, 45 users are, going to websites they shouldn't be at, and now I don't have enough bandwidth going out to the internet for my e-commerce. Okay? Your users are denying service to the legitimate practices you want to run in your business. Right? Those I see commonly. I'm sure we all see those. How do you stop that? Well, you use things like NBAR and quality of service to make sure that you allow traffic that you want in your network. Yes, sir? Now, you're referring to the performance issues, right? You want to know about the performance issues of this design. And absolutely. And, thinking about this, it's like, well, does routing take more processing than switching? Sure it does. But when you're talking about these boxes that now you're routing at the ASICs, your performance difference is negligible. Unlike before where your routers took such a big hit going through, now we're routing at wire speed. There's no performance hit. Now, ACLs can create issues. Okay? Where do you want to extend this? Do you want to extend the security all the way down to the access layer, which you can now at this point? Yeah, you can take a hit. Depends on the size of your ACLs. Absolutely. Okay. Any other questions? Sure. It's the amazing brand loyalty of Cisco that means, that makes Cisco have 90% of the market share. I see, I'm sorry, the question was, is there other boxes out there that'll do a better job? Sure, I've seen boxes that perform a lot better. Cost certainly is a factor, and in this design, I will tell you right now that is not cost effective. It certainly is not. It does not make sense to buy a 24 or 48 port switch that costs you list about $10,000 to run this design. Right now, it doesn't make any sense, but it will soon. Right? I'm saying probably within the next few months, it's going to become less and less expensive to run this design. Okay? And this is an emerging idea. It's not, it's something that we thought about a long time ago, but for the very same reason you asked, is there a performance issue? There was a performance issue. So you couldn't run this design. But now that the performance issue is no longer there, so to your question of can you do this other boxes, of course. Lots of other vendors can do the same thing. The brand loyalty, just amazes me. There was a story from one of my students about, going to networkers, and he was competing on, voice over IP server products similar to the call manager line. And they were at networkers together, and he was, talking, and they had a whole crowd of people just pegging the Cisco engineers about why doesn't call manager do this, and why doesn't call manager do that, and it doesn't work here, and it doesn't work there. And the Cisco engineer said, yep, doesn't work, can't do that. Can't do that. And everybody in the crowd said, okay, we'll wait. And the company he was working for had a completely competing product that did all those things, but there wasn't a single person that was even willing to talk to him because everybody's so brand loyal to Cisco. Is that a good thing? Maybe. Certainly nice to have a network of the same gear, but does it, create its own security problems as well? Right? Once you create one attack against one box, it's very likely to be vulnerable on all the rest of them. So I can't answer the fact whether or not that's a good design or not, because the other side of it is if I've got a mixed vendor equipment environment, I've got a training issue, and that in itself creates its own security problems. I don't know how to apply all the security features of box X where I do know how to do it on box Y. Any other questions? Need more questions so we can, have. Yeah.
They're so cheap compared to trying to get a managed switch. It just, I mean, from the higher levels, yes, but to create a redundant system, sell to me for $50, and that's still a lot of money.
Yeah, no, I can't argue with the cost issue. But I can say the technology's there to do it now. And that's really what I'm trying to say, is that I found a solution to some of our problems. I found a solution to all these attacks that we're seeing right now, a possible solution. Now, I'm not saying it's perfect. It's certainly not. There's a lot of things that would have to be fixed on it, and the cost being one of the biggest ones. That being said, the things I'm seeing right now with Cisco's product line, things like the 1900 and the 2900, the switches that were typically put at this access layer position are now end of sale, going away, and the things that are being pushed are the 3550s and those boxes. They've got to come down to be viable in the rest of the market. So I see this design being very close to reasonable and deployable. All right, so here's just kind of a design look at of what I was pointing out, that every port on the switch is on a different VLAN. The upstream connections running gigabit Ethernet going upstream. Every port is essentially an access layer port, so we're not doing any kind of trunking. We're routing upstream. Really, if it's OSPF, you were mentioning OSPF areas. This in itself can become its own OSPF area, and we just summarize all the traffic going upstream, so we don't have to carry a route for every single VLAN that we have. So the upstream switches see one route for the entire access layer switch that's downstream, which makes sense and is completely redundant. All right, that was a majority of the content I had. I did have some open discussion topics that I wanted to go through, and I knew, that. So these aren't in the book. There's a lot of flack that has been thrown at all these protocols that are up here, and I just wanted to just kind of open up the floor, and if you guys have any questions on the attacks and defense currently, notwithstanding the design ideas that I've thrown out here, any attacks against these protocols that you have questions about, let's talk about them. And I've got another slide on layer 3, and I've got another slide on management. So if we right now hold the the discussion just to layer 2 attacks and layer 2 defense, what questions do you guys have? Yes, sir. Okay, a little louder. Your question is how to stop ARP spoofing. Okay. This is the one that I don't like to answer because it's very difficult, right? The solutions I've seen work are the solutions that I don't like because of the cost and because of the other things that people use it for, and that is network IDS. Okay. Although network IDS works for that problem, it does work. Okay. The other solutions are coming. As far as that firewall idea, firewall at the box to where it will stop ARP spoofing and stop DHCP takeover attacks, those are realistically coming, but network IDS works. There's also ARP Watch that will mitigate the problem. So that works, but it's an extremely expensive thing to deploy because look at where you have to deploy it. If this is your design that you're looking at, look at all the network IDS boxes you're going to have to put out there and the cost of those boxes. You were wondering about cost. Well, why not go to the other solution that I'm talking about, and now you can't ARP spoof. Okay. So, any other questions? Okay, go to layer 3 attack. You guys sure? No more questions on this? All right. Layer 3 attacks, things like HSRP, GRE tunneling attacks, any kind of attacks based on our routing and insertion attacks into OSPF and EIGRP, I talked about all these attacks during my 2-day class. Lots of ways to really maliciously use these protocols. And I've kind of picked on HSRP a little bit, but GRE tunneling, where if you have a tunneling, and we're talking about tunneling attacks over, not over VPN encrypted tunnels, but unencrypted tunnels. If you're running a unencrypted tunnel without any kind of key ID, you open up a pretty big security hole, where I can really just inject packets into that tunnel. It will take it and send them right back to me, or you weren't going to be expecting them. Routing protocol injection attacks, I mentioned, BGP attacks. Any questions you guys have on how they work, or possible defenses on them? Okay, so my idea of an open discussion isn't working. Okay, about GRE attack. How a GRE attack works. Let's envision, a couple routers attached to the internet. Okay? Different locations, different branch offices, and I'm running IPX. Okay? Running IPX, and I want to carry this IPX traffic across the internet. Of course, my service provider tells me no, can't do that. Okay? And I say, why not? Because it's the internet. It doesn't work. So I create a tunnel. Okay? Create a GRE, which stands for Generic Routing Encapsulation Tunnel, which essentially is going to put an IP packet on top of a IPX packet. Or pick another protocol. I can do IP inside of IP, where I have private address space sitting on one side, private address space sitting on the other, and I want those private addresses to be able to talk to each other via the internet. Well, in order for that to work, I need to tunnel the traffic. Well, that's all, that solution's been sold over and over and over. But without encapsulation, it falls apart. All you have to do as an attacker to get in between, not really in between the conversation, not a man-in-the-middle attack, but rather just the ability to talk to the devices that are talking via this tunnel. If I have knowledge of the tunnel, however I gain knowledge, all I have to do is encapsulate my packet as an attacker packet somewhere else on the internet. I should probably draw some stuff out here, but I can send my GRE tunnel packet, my destination packet. It's marked as GRE, so they know there's something else inside of it. The destination is the legal internet address of, let's say the headquarters router that has the servers behind it. So I'm sending a GRE packet to that destination. And the source address, let's just spoof it to be the original, source port at the other side of the tunnel. So it looks like it's a regular tunnel packet from the router who receives it. Everybody else on the internet is going to carry that normally. It gets over there. The router looks at it, says, oh, this looks fine, passes all my access lists, passes the firewall, because the firewall was expecting this, gets to that router. Router strips off the GRE header, and what is it left with? Well, what packet did I create inside there? Here's my address is the source. The server's address is the destination. That's the private address of the server that we couldn't get to normally. The router sends it normally right over to the server. Server looks at the destination address or the source address to send a message back. And this looks like brand, it looks like a connection going outbound from the server. Now, is it a brand new connection? Is the firewall going to stop it? Maybe. There's a firewall in place. If there's no firewall in place, that connection goes back out to the router. The destination now being the original attacker's device may have to do some network address translation. It might have been, an IPX type thing, so it'll tunnel it. May not be able to get that packet back if it's IPX. At least you can get it in there. What can you do with it after it's there? Send a whole bunch of it. But if it's IP over IP, I can get those packets all the way back and talk back and forth to the server that I otherwise couldn't reach because it's got a 192.168, 3.3 address. Okay. Yes, sir? How do I get it? I can do a port scan for it over that same tunnel attack. Okay. that was a great idea, but he wanted me to pull up some slides from my class showing some of the tunnel attacks. Unfortunately, I don't have the slide presentation on this laptop because during the class, this laptop was a Windows 2000 server with no patches whatsoever, and I told all my students that if it wasn't completely compromised by the end of the day, I was going to be very disappointed in them. So, no, I don't have the slides for my class, unfortunately. So, or I could bring those up and show you guys. Okay, did I answer your question though? Okay, great. Any other questions on, let's say OSPF or EIGRP problems? Some of the OSPF attacks I've seen. OSPF, and really my ideas of some of the denial of service attacks against routing protocols themselves, against spanning tree, against these other protocols, really stems in the fact that it's very well advertised that these are the weaknesses of pick a protocol. OSPF only expands to 250 routers effectively and within an area. Spanning tree domains can't go beyond a certain point, have a 50-second timeout as far as reconvergence. Well, a lot of the attacks from a denial of service perspective, all you have to do is read what the problems are with the protocol and replicate that in your attack. I send 500 hello messages all with different neighbor statements going to all the routers, and I guarantee OSPF's going to just freak out. It's going to stop working. I start sending change notification flags, upstream, dropping all the timeouts on the switches to 15 seconds for all the switches there, for all the CAM table entries, and things start flooding all over, adding a tremendous amount of traffic to my network because of that. Or I just send, get this, I send a root bridge, hey, I'm the root, and then stop talking. As soon as that one message goes up, there's a root, re-elect, and all of a sudden the root's not there, and now we re-elect the original root, and I send it again, 40 seconds later. It took 50 seconds to re-elect the other root, so every 40 seconds I'm the root again. That takes down your entire layer 2 environment. Take down a whole VLAN, taking an entire spanning tree domain. Just looking at the timers and basing those denial of service attacks just on the weaknesses of the protocol themselves. A lot of our attacks, as far as getting things to do things that they're not, are based on, buffer overflows, memory overflows. But as well, the same type of things can be applied to pretty much every protocol we have. I particularly like some of the BGP exploits that come into play of flooding a BGP neighbor so it drops all of its connections and it drops all of its other neighbor statements, and then comes up and reestablishes, and we do it again, and it comes up and it reestablishes, and we do it again, and now the upstream ISP goes, we're not playing that game, and does a BGP route flamp dampening, and you don't have routes being sent and carried throughout the internet for half an hour. Your whole site's down for half an hour. Just by sending a bunch of TCP 179 messages to the BGP routers. And that can be done over and over and over. And 9 times out of 10 it works because BGP, most people don't authenticate BGP. The features are there to stop these things. OSPF has authentication, although it can be replayed. That was mentioned by FX. But a lot of these things can be stopped. They can be stopped with access lists. They can be stopped with just simply good design. Good design, both from a security perspective and from just an overall infrastructure perspective. All the way from the wires. Are the wires in the right places? Okay? If you don't have good wires, stop. Build your network from layer 1 all the way up. Don't start from we need to run these servers. Yeah, that's fine because I know you need to run certain applications, but you need to build your network around that. And the overall concepts, and I'm running out of time here, so I'm just kind of going to wrap this up. The overall concepts, the credo of Black Hat has been layered security, okay? Also layered design. Okay? All of these attacks we've seen, we kind of sometimes forget about the things that are the more simple side of things, the things that I need to take this box out of service to upgrade it. That's a very important part of security. And if you don't have a good design that supports that, you're not secure. Don't kid yourself. Because if I can't upgrade it while the network is live, I'm vulnerable to attack until I can fix it. And I'm going to wait until I really want to come in at 1 o'clock in the morning and upgrade iOS on that box. And I don't want to. As a company owner, I don't want to pay my engineers overtime to do that every single time there's a new exploit that has to be fixed. So from a design perspective, that has to be thought of. And that's part of the layered design, or the layered security, is that thinking about things, from the users, from the administrator's perspective, to give them the capability to apply these patches, to apply new iOS to fix things. Other new things that are out there, I was going to wrap up, but I did want to mention the new SSH thing that just recently came out. Did everybody read that advisory as far as SSH on Cisco boxes? Most Cisco boxes are vulnerable to it. It's after all this time, we've been dealing with Telnet. We know Telnet's about as it's about as secure as the barn door, right? So everybody's trying to, from the cost perspective, it's expensive to run SSH, but okay, we'll run SSH. Right? And now the first thing that comes out is somebody decides, hey, let's just send a packet of SSH with a bunch of garbage in it, fill it as big as we can send it, and send a whole bunch. Spikes the CPU up to 100% and crashes the box. I mean, that wasn't hard to figure out. Right? So that'll be fixed eventually, but what do we have? What's the alternative? We go back to Telnet? Right. So from a likelihood standpoint, I'm still never going to suggest going back to Telnet if you've already made the switch over to SSH. And I still say everybody should switch management of these devices over to SSH, without failure, without even in regard to that problem. That problem can be solved with creative access lists. Although you have to create the access, you can't use access class, which says only certain devices can SSH to this box, because as soon as it hits the interface that it came in on, that's where the attack takes place, not at the actual virtual terminal where you can stop certain attacks. So you would have to place access lists in places where you may not necessarily want to from an SSH perspective, but it can be gotten around. Yes, sir. You're commenting on doing management interfaces out of band. I agree. As far as building an out of band management network is is a very good idea. I like it. From a cost perspective, I see a lot of people cringe at it. Okay. This design that I'm showing you can be a very large network, but also can be extended down to relatively small networks. If you're in that environment where it's a relatively small network, you're not going to see the need, although it's there. You're not going to see the need to do that kind of security. And this is where we have to, on a day-by-day basis, deal with this is the best practice, but we don't have the money to follow the best practice. So what's our next best option? Well, certainly running SSH is one of them. So yeah, no, I agree. I agree completely. But I also see the compromises that are there as well. Absolutely. Any other questions? How are we doing on time? About 5 minutes? I think even with 5 minutes, I think I'm pretty much done. Guys, go enjoy DEF CON. For those of you who guys are sticking around, I hope you guys enjoyed my talk. See you guys next time.